Alright, this is the Unit 7 review. Better late than never. I've been told to be more lively. I'm more enthusiasm when I do this, so here goes. Here's my more enthusiasm. Number one, choose the definition of a circle that is most accurate. I'm going to tell you why all of these are wrong except for D. D is your right answer. D, you need to find the set of all points in a plane. You must see those words in a plane that are equidistant from a fixed point called the center. A, the set of all point equidistant from a point called the center. You don't know where that is. It's not in a plane. It's not in space. You don't know where it is. Two lines that in the same plane that do not intersect. That's parallel lines. That's not a circle. And the set of all points in space. Here's how they're going to try to trick you. In space, this is the definition of a sphere. Must be in a plane. Circles are two-dimensional, so you need it to say in a plane. Number two, convert 3 pi over 2 radians to degrees. So you have 3 pi over 2 radians. To convert that to degrees, you're going to multiply by the conversion factor, which is going to be 180 over pi. Pi divided by pi, the pi simplify. You can simplify 180 and the 2. 2 simplifies to a 1, 180, half of 180 is 90. And then 3 times 90 is 270 degrees. There you go, that's your final answer. Number 3 says to solve for theta or solve for your variable. And it gives you this picture. Since the lines intersect inside the circle, that means I am going to use the formula theta equals arc1 plus arc2 divided by 2. In my picture, arc1, theta is my x. Arc1 was 120, arc2 was 70 divided by 2. Very easy, very straightforward. This becomes 190 divided by 2, which is going to be 95 degrees. Next one is to find the perimeter of the ice skating rink. Perimeter is the outside edge. So we're trying to find the outside edge of this ice skating rink. What I failed to tell you was from here to here is 15, and from there to there is 8. So right now as this sits, I'm just going to draw a rough sketch. The circles, this is a super rough sketch. This is 15, which means this side is 15. I said this was 8, which means this side is 8. Let's zoom out. That means I need these curves. The diameter of these circles is 4, which means the radius is going to be 2. This is a 90-degree angle. If the radius is 2 and that's 90 degrees, that means the arc is also 90 degrees. So I'm trying to find arc length, which is going to be circumference 2 pi r times theta over 360, where my theta is 90. So I have 2 times pi times my radius, which is 2, times 90 over 360. And I'm going to simplify this. 90 goes into 360 4 times. So 2 times 2, 4, pi, and this will simplify to 1/4. Now 4 divided by 4 is 1, so all you're left with is pi. So this arc length is pi, this arc length is pi, this arc length is pi, this arc length is pi. So to find the perimeter, you just add them all up. You have 8 plus 8 plus 15 plus 15 plus pi plus pi plus pi plus pi. And I know a lot of you are saying, what the freak did you do that for? There's a lot easier way to write it down. You're right. 8 and 8 is 16. 15 and 15 is 30. And this is 4 pi. 16 and 30 is 46 plus 4 pi. So on your calculator, make sure you use the pi button. You have 4 times pi, which is 12.56 blah blah blah, plus 46. So the perimeter of this is approximately 58 point, does it say where to round? No. 5, we'll round to the tenths or hundredths. 5, 7. Next question. Fan oscillates 250 degrees. So we're trying to find this shaded area, which is the area of a sector. Area of a sector is pi r squared times theta over 360. My radius is 4, so you have 4 squared pi times the angle. It says the fan oscillates 250 degrees. So 250 over 360. Again, I like to simplify my fraction. 4 squared is 16 pi. I can simplify this by 10, so it becomes 25 over 36. No other numbers simplify into there. I can, however, simplify. I won't even worry about it. I'll just plug it in a calculator. You have 25 divided by 36. It equals times 16 equals times pi equals, so this is approximately 34.9 square whatever, square feet. Six, if the measurement of angle JMB is 70 degrees, again we have a picture. If JMB is 70 degrees, your radius is 5. Find the arc length. Arc JB, arc length is 2 pi r times theta over 360. My radius is 5. 70 over 360. 2 times 5, this is 10 pi. This simplifies, you can divide both by 10. 7 over 36. Now you just multiply. Seven divided by 36 equals times 10 equals times pi equals, so it's approximately 6.1. 7, what is the radius of the circle? Here you go, x squared plus y squared minus 10x plus 8y plus 16 equals 0. You need to put the circle in standard form. Get all your variables together. X squared plus 8y, or 8, no, sorry. X squared minus 10x, and then you have y squared plus 8y. Move your constant to the other side, so this equals negative 16. Take half of this, which is negative 5, then square it. So add 25 to both sides. Do the same things with your y. Take half of it, which is 4. Square it, which is positive 16. Add that to both sides. Now the question says, what is the radius? I can put this in standard form now. It's x, use this, minus 5 squared plus y plus 4 squared equals, well, negative 16 plus 16, these wash each other out, that's 0. 25. 25 is not my radius. 25 is my radius squared. So the square root of 25 is my radius, which is 5. Don't let them trick you on these questions. Alright, 8. You have this circle. They said the center is, no, they didn't tell you the center. They told you the diameter was negative 3, 5, and negative 3, negative 3. If that's the diameter, then half of the diameter would bring you to the center, which is here. Then you can count the radius, which is 1, 2, 3, 4. So if I go 4 in each direction, there's my circle. So if I graphed it, and this is a multiple choice answer, I can then figure out which one is also on the circle. If I need to figure it out mathematically or algebraically, I can, because I know the radius is 4. So wherever that point is, if I plot a point, I can always create the right triangle and use the Pythagorean theorem to see if the hypotenuse is 4. So there's two ways you can do it. Obviously, if you draw this circle, I know this isn't a good circle. If you plot the points on a multiple choice question, if it's down here, you know it's not the answer. If it's in there, you know it's not the answer. There's only two that are going to be close. One of them might line up exactly, or you might have to do the distance formula, Pythagorean theorem, to figure out that the radius is 4. Alright, 9. Use the figure below to figure out how. Alright, this one. Let's draw it. This is 112, 62. Alright. They're asking for the measurement of ABC. And this is A, B, C. ABC. So I need this, which is an outside angle. The outside angle is equal to your large arc minus your small arc divided by 2. I have my small arc. I need my large arc. How do I get my large arc? I need this theta. To get that one, it's just, this is a straight line, 180 degrees right here. So 180 minus 112, this is going to give me 68 degrees. Now the inside angle, I'll do this one down here. The inside angle is equal to arc 1 plus arc 2 divided by 2. So I know my theta, 68, is equal to, I'll say arc 1 is 62 plus arc 2 divided by 2. Multiply 2 to both sides, and you have what is that? 636 equals 62 plus S arc 2. Subtract 62, and this becomes 74. So this is 74 degrees. Back up here, your theta is going to be equal to 74, your large arc, minus 62, your small arc, divided by 2. 74 minus 62. This is 12 divided by 2, which is 6 degrees. A lot going on in that problem, but none of it's too difficult. Bear with me. This is me being more exciting. Alright. Next, circle Z is given below. They gave you KL and MN. I zoomed in a lot. I'll just read it. KZL and MZN. KZL, the angles are congruent. What is the measurement of the chords? Well, if your angles are equal, your chords are equal. So you're going to take both of these chords and zoom back out. So you have x plus 7 equals 2x minus 4. If the angles are equal, the chords are equal. So I'm going to subtract x. 7 equals x minus 4, add 4, and 11 equals x. It says what is the measurement of KL? KL, since they're both equal, it really doesn't matter. So x plus 7, this is going to be 11 plus 7, which is 18. A chord was cut in a circular pizza. The chord is 10 inches. Here's your pizza. The chord is 10 inches long and its midpoint is 4 inches from the center. So here's your chord. Here's the center. This is 4 inches. What is the diameter of the pizza? So in order to figure out the diameter, I need to figure out the radius. If the chord is 10 inches, the midpoint of the chord splits that in half. So that means this is equal to that. So that's 5. This is 4, that's 5. This is a right angle. So we're using the Pythagorean theorem, which is 4 squared plus 5 squared equals c squared. 20 plus 25 equals, that's not 20. Bad math. 16 plus 25 equals c squared. This is 41 equals c squared. So c equals the square root of 41. Double that to get the diameter. So the diameter is 2 times the square root of 41. Which, in the calculator, is approximately 12.8. Next, TCHS is replacing some grass in the field. What is the area to the nearest tenth that the grass needs to be replaced? This is a right angle. How do you know? Because the arc's 90 degrees. So I need to find the area of the sector, the area of the triangle, and the area of the rectangle. Area of the sector, area of the triangle, area of the rectangle. If I find the area of the sector and subtract the area of the triangle, that gives me the area of this little curved piece up here. If I subtract that from the area of the rectangle, that'll give me the shaded area. Let's see if I can do this in different colors. If I find the area of the blue, which is the area of the sector, I'm going to subtract the area of the triangle, green, then I'm left with the white area, or the red area. And then if I subtract that from the area of the rectangle, I'm left with my answer. So let's do the easy stuff. The area of the rectangle, 15.6 times 4.2. The area of the rectangle is 15.6 times 4.2. So the area of the rectangle is 65.52. The area of the sector, pi r squared times theta over 360. Your radius is 9, so 9 squared pi. Theta is 90 over 360. We already figured that out before that. That's 1/4, which gives you 81 pi over 4. So if I do okay, 81 times pi divided by 4, that is approximately 63.62. Then the area of the triangle, oh, I messed this up. This was the rectangle. That's the triangle. Triangle is 1/2 base times perpendicular height, which is 9 is the base, 9 is perpendicular height since it's a 90-degree triangle, divided by 2. 9 times 9 is 81 over 2, which is going to be 81 divided by 2. This is 40.5. Now what I said before, I'm going to take the area of the sector, which is 63.62, and I'm going to subtract the area of the triangle, 40.5. 63.62 minus 40.5 equals 23.12. This is the area of the red. So if I subtract the area of the red from the area of the rectangle, I'll be left with my answer. So the area of the rectangle is 65.52 minus 23.12. 65. This is a long problem. Most of you are going to give up and not do it. I highly, highly, highly encourage you not to. But at the end of the day, there's no way for me to stop you. Watch this problem again. 42.4 is your final answer. Watch this problem again. This is not very hard. You're finding the area of 3 things, 3 different things, then you're just subtracting them. You're going to subtract these 2, get an answer, subtract it from this, and you're done. That's it. Okay. 13. Almost done. 3 more. 3 more, I think. 13. 2 more. Find the equation of the circle with the center 4, -2, and a radius of 3. The equation of the circle, x minus h squared plus y minus k squared equals r squared. H and k are your center. Opposite signs. So if the center is at 4, negative 2, x 4 is positive, so that means it's negative inside the equation. Negative 2, well, that's negative, so that means it's positive inside the equation. And your radius has to be squared. 3 times 3 is 9. There is the equation of the circle. Last one is the proof. Proof. Love proofs. That's how I go to bed at night. I do proofs. Given theta 1 is congruent to theta 2 and they're measured in radians, prove the similarity of these triangles. Okay. Or circles, sorry. Similarity of the circles. All circles are similar. That's just known. Every single circle can be dilated onto each other, so they're similar. We need to prove it that they're both equal to theta, the ratios. The only way to do that, they give you the radius, theta, and the arc length. So if using the arc length, which is equal to 2 pi r times theta over, normally I would say 360, but they told us in the directions that this is radians. Radians is not measured in 360 degrees. The whole circle in radians is 2 pi. So I'm going to call this circle 1. And I'm going to call this, actually we'll just do circle 1 for now. So in circle 1, you have arc 1 is equal to 2 pi times radius sub 1 times theta sub 1 divided by 2 pi. So 2 pi divided by 2 pi, this is why they told you it's in radians, so that you would get the 2 pi. They simplify and you're left with the arc 1 is equal to radius sub 1 times theta sub 1. So if I divide by the radius, I get,
I'm going to leave that there. And I'm going to do the second circle over here. Arc 2 is equal to the same thing, 2 pi radius sub 2 times theta sub 2 over 2 pi, not 360, that's the key. They told you this was radians so that you would get 2 pi, so that would work. You get arc 2 is equal to radius 2 times theta sub 2, divide by your radius sub 2, and you get arc sub 2 divided by radius sub 2 equals theta sub 2. So I have both of these equations. What do I know about it? Well, right here, they told me my two thetas were equal. Can you see that? There you go, that's me being funny again. Everybody stop complaining to their teacher. I'm funny on these videos. Theta 1 is equal to theta 2. Right there. Given. How do you know? Because I can read. Since theta 1 is equal to theta 2, that means arc 1 over radius 1 is equal to arc 2 over radius 2, which is equal to theta, which is what we were trying to prove. Right there. Proven. Draw your box. Color it in. I'm done. And so is this video. I know it's late. I know some of you are testing tomorrow. You'll get over it. Watch it a couple times. Watch it at lunch. Watch it before school. Watch it on your way to class. I don't know. I don't care. Watch it. Study. Make sure you score high on this test. A lot higher than you have.